Alright, in this video I'm going to introduce the idea of magnets and magnetic fields. So a magnet, let's just use our stereotypical magnet. So we have a bar magnet, and certain types of elements that are found on the periodic table or metals actually have magnetic properties, and this is because of the spin of the electrons in certain domains, they're called, within the magnet. But it's really the movement and the spin of the electrons that generate the magnetic field and give it its magnetic property. So magnets always have a north and a south pole, and a magnetic field is a field, so it's going to have vectors or field lines just like an electric field does. So for magnetic fields, the magnetic field lines are always drawn in the direction of from the north to the south. So if I were to draw magnetic field lines here, you could see here that they go from the north to the south. So they always come in pairs. And this is much like, or it should look a little bit like, the dipoles that we saw when we were looking at positive and negative charges. So a magnetic field actually has a quantity too, and it's written with the letter B. So a magnetic field has the variable B, and it has a unit called a Tesla. And the Tesla actually comes from it's a derived unit, and we'll look at that in the next video where we actually see what the definition of a Tesla is, and it's based on a charge moving through a field. So we'll just look at that later, but for now, just know that the unit is Tesla, written with a capital letter T. Now, the other thing that I'm going to talk about in this video is sign conventions for magnetic fields. So magnetic fields are three-dimensional. So we also know that electric fields are three-dimensional, and in this case we've only got 2 dimensions of the page. When we looked at electric fields, we were only dealing with just electric fields, so it was okay that they were 2-dimensional. We always just placed them in the plane of the page. But now we're going to start talking about electricity and magnetism in conjunction with one another, and they're actually perpendicular to one another. So we have to develop a convention for a magnetic field that is moving either not in the plane of the page, but is moving out of the page or into the page. So that's the last thing I'm going to show you in this video. We're just going to look at the sign conventions. So if you see a bunch of X's, sort of evenly spaced apart like this, X means that the magnetic field, or whatever that X is applying to, is going into the page. So the direction of this magnetic field would be down into the page. Now, if we looked and we saw a bunch of dots, okay, something like this, this is a convention that means that the magnetic field is pointing up and out of the page. Out of the page. Now, on the AP exam and on all the tests and everything that you'll see, it usually uses the X and dot system, but also in the question it will clarify just so that you're sure. It'll say this is a uniform magnetic field and pointing into the page. So if you don't remember the X's versus dots, it most likely will be clarified for you in words. Alright, in the next video I'll go more into detail about how electricity and magnetism are combined with one another.